Alright, today we're going to start Unit 2. Unit 2 is about logic and proofs. Our first lesson is we're going to talk about conditional statements and related conditionals. A conditional statement is a statement usually written in if-then form, and it follows the format that if P, then Q. P will be the hypothesis of the statement, and Q will be the conclusion. So if hypothesis, then conclusion. So for example, if the measure of angle A is 95 degrees, then angle A is obtuse. So your hypotenuse is the measure of angle A is 95. The conclusion is angle A is obtuse. So this hypothesis is P, and the conclusion again is Q. In this example, you're going to determine the hypothesis and the conclusion in the two different statements. I'll work the first one with you. The first one says, if you are in Houston, then you are in Texas. So again, the hypothesis is everything that follows the word if. So I would put a bracket around it. And again, it's P, or your hypothesis. The conclusion is everything that follows the word then. So I would put a bracket around it. And again, it's Q. So the hypothesis is you are in Houston, and the conclusion is you are in Texas. So with that, you should be able to answer question B. Example 2 wants us to write the conditional statement from the sentence, two angles that are complementary are acute. So usually when you're given a sentence and asked to write it, you gotta write it in if-then form. Sometimes you need to add words in order to make the sentence sound more grammatically correct, but try not to alter the meaning too much. So for this example, I decided to write, if two angles are complementary, then they are acute. Again, the only words I added were if, and then, and they. So again, I didn't alter the meaning of the statement, but I did have to add a few words to make it grammatically sound. Now we're going to start getting into some of the related conditional statements. Again, we have our original conditional statement, if hypothesis, then conclusion. In symbols, you're going to see me write P, and then that arrow stands for the word then or implies. So P, and then again, this means implies. So P implies Q. Now, we're going to talk about the converse. The converse is when you exchange or switch the hypothesis and the conclusion. So the hypothesis becomes a conclusion. The conclusion becomes the hypothesis. So converse, you simply just switch the order. Don't move if and then, just simply switch the hypothesis and the conclusion. We have an inverse statement. An inverse statement is when you negate the hypothesis and the conclusion. When it says negate, well, look at the word inverse. The prefix in usually means not, or some relation to the word not. For example, insufficient means you're not sufficient. Inadequate means you're not adequate. So when you see the word inverse, remember to add the word not whenever possible. So you're gonna most definitely by the verb in the statement. So it'll be if not P implies not Q in symbols. And we're going to practice writing each one of these types in just a moment, so just be patient. And the last word is contrapositive. Contrapositive is not only do you add the word not, but then you reorder and switch the hypothesis and the conclusion. Now, a lot of these statements are going to have a truth value. The statement will either be true or false. In order to say it's true, it has to be always true. If it's sometimey, you're going to say false. So what you should notice when you do the validity testing true or false is that the converse and the inverse will always have the same value, either both true or both false. And then the original statement and the contrapositive will have the same value as well, either both truth or both false. And when that happens, it's because they are what we call logically equivalent. So the converse and the inverse are logically equivalent. The original and the contrapositive are also logically equivalent. So now we're going to take this provided conditional statement and write the three related statements. Also determine the validity. So the statement says, if the sum of two angles is 180 degrees, then the angles are supplementary angles. So what I would do if I were you first and foremost is establish what P and Q are in the statement. So P again is after the word if. So after the word if until you reach the comma. So this is P. And Q is after the word then. Q. So again, the original statement was P, then Q. So for the converse, you're switching roles. So it's Q, then P. So the statement would read, if the angles are supplementary angles, then the sum of two angles is 180 degrees. I simply just put P where Q was, put Q where P was, and that's all. The inverse statement was when we had to add the word not. So we're going to say not P, then not Q. So the structure, P will be in its original place and Q will be in its original place. The only difference is you add the word not near the verb. So it would read, if the sum of two angles is not 180 degrees, then the angles are not supplementary angles. And then last statement is the contrapositive, which is when we add the word not and we switch. So not Q, then not P. So you take your inverse and simply just switch them. So it would read, If the angles are not supplementary angles, then the sum of the two angles is not 180 degrees. So now we have to determine the validity. When that statement is given, that means you have to state whether it is true or false. So let's go back to the original. If the sum of two angles is 180 degrees, then the angles are supplementary angles. We talked about this in the first unit, and that is definitely true because supplementary means add up to 180. Now let's look at the converse. If the angles are supplementary, then the sum of the two angles is 180 degrees. That is still a true statement. Even though I changed the order, if you listen clearly, it still has the same meaning. I did not alter the meaning. The inverse says, if the sum of the two angles is not 180 degrees, then the angles are not supplementary. That is also true because, again, the original statement said if they add up to 180, then they're supplementary, and we said that was true. So obviously, if they don't add up to 180, then they won't be supplementary. And the last one, the contrapositive. If angles are not supplementary, then the sum is not 180. Again, that is true. And since all of these were true, you should notice that logically equivalent component where, again, the original and the contrapositive will have the same value. The converse and the inverse will also have the same value. So they're logically equivalent. Alright, the directions are the same for this one, just a new conditional statement. Make sure when you read these things, you read them as they're written and pay very close attention to detail because some of them are going to try and stump you. So it says, if you live in Humble, then you live in the Houston area. So the hypothesis is you live in Humble. So that's P. The conclusion is you live in the Houston area. That's Q. So again, it's written in P then Q format. So now the converse is again Q then P. So switch the order and you would have, if you live in the Houston area, then you live in Humble. Now the inverse. Inverse means add not. So not P, then not Q. So if you don't live in Humble, then you don't live in the Houston area. And then we have to write the contrapositive, and we write it in the format of not Q, then not P. And it would read, if you don't live in the Houston area, then you don't live in an Humble. So now we're going to determine the validity. And this is where it gets a little tricky. If you live in Humble, then you live in the Houston area. Is that a true or false statement? It is a true statement because the Houston area covers a large span of space. Basically, if you're in Harris County, you're in the Houston area. So if you're in Humble, you're just a small suburb of the Houston area. Okay? Now, look at this one. If you live in the Houston area, then you live in Humble. Now, just because I'm in Houston doesn't mean I'm in Humble. I could be in Bel Air, I could be in Spring, I could be in the Galleria. So this is false because, again, Houston is so big. Just because you're in the area doesn't mean you're automatically in Humble. All right, the inverse. If you don't live in Humble, then you don't live in the Houston area. Again, that's false because I don't live in Humble, so I could I could live in Spring. I could live in the Galleria. I could live in Sugarland, but I'm still in Houston or in the Houston area. So again, that's not false. Anytime it's some gray area or sometimes, you're going to say false. In order to say true, it has to be true always. Now, the last one. If I don't live in the Houston area, then I don't live in an Humble. And that would be true. Because, again, you have to be in Harris County in order to be in Humble. So, if you're not in Harris County or the Houston area, then of course you're not going to be in Humble. So now again, you should pay very close attention to that logical equivalent connection. My converse and my inverse were both false. Again, because they're logically equivalent. My original statement and my conditional statement were both true. Again, because they're logically equivalent. Please work on this example in your notes by yourself and take a picture. I will check it next time I see you. And this concludes your notes for the day.